Okay, hi. Hi, everyone. Thank you. Okay, so I'll be talking about Python-powered disease classification web applications. It's a mouthful, but yeah, it's right there. Python-powered disease classification web applications. So a bit about myself. I'm Daniel Madaliso Phiri. My middle name, Madaliso, the T is silent, means blessings, and I'm hoping I can spread some across the room. I'm a co-organizer for a conference called DevCon ZM. That's the annual developer conference in Zambia, and you can find me literally anywhere online by Malgamves. So that's Malgamves. Okay. So just a side note, I really like engaging crowds. So can I hear some energy? No, like some real energy. Yeah. Okay. So let's maintain that. Okay. Yeah. Great, okay, because you give me the energy. Cool? Yeah. All right, cool. Yeah, so yes, Python-powered disease classification web applications. What is that, right? How many people are curious? And in the back there, no one's interested? Okay, cool, yeah, okay. It sounds like a lot, but it really isn't. This talk is basically about machine learning, and how many people have done anything close to machine learning before? Okay, how many people have used scikit-learn before? There you go, you're a machine learning engineer. So machine learning is basically telling computers to do something that you didn't explicitly program them to do. And I'll explain more about this as I go on. I'll tell a bit of my story. I made a joke when I was asking a question. Someone was like, don't, tell us your life story. I'm like, I'm pretty young, so my life story is pretty short. So I just finished my computer science degree, and when I started that, we had Python as a class. And I'm like, okay, what can I do with Python? So I think pretty much everyone takes this journey. They make like a simple game. They create some variables. Everything's dynamic. Python's pretty cool. And then I'm like, okay, what more can we do? So I'm like, machine learning, right? So I get into TensorFlow. I get into scikit-learn. It was that time when everyone was like, machine learning was the in thing. Everyone wanted to be like a data scientist. Everyone, was installing TensorFlow and then just leaving it there. So it was a nice time, and it was really cool. So yeah, it was basically you get a machine learning, you get a machine learning, you get a machine learning. Everyone gets a machine learning, and yeah, it was very hyped. But then it leaves a lot of questions. What actual effect can we have in society with machine learning? And I really like that the keynote speaker yesterday mentioned having actual projects on the ground affecting people's lives. They have the flood thing that they have in India where they predict which area is going to be flooded, and that's a really cool resource, and they can predict whether and diagnose diabetic retinopathy. I'm not like medical, so yeah, it's an eye disease, and it's really hard to predict, but machines, when trained explicitly to do that, do it far much better than humans, and that's pretty interesting. So yeah, you probably get it. Machine learning was cool, but what effect does it have on society, right? Cool. So the whole issue is solving complex problems, and that's what I'll be getting into, and that's why I call this presentation Python-powered disease classification web applications. All right, so how many people here have used something that's known as a Jupyter notebook? Okay, just so that I don't alienate everyone, I'm going to run a simple Jupyter notebook. So I'm in my terminal, and all I have to say is Jupyter notebook. So it's a really interactive way to run Python code in your browser. That's basically what a notebook is. It might take some time to come up, but basically you get these cells and you type in Python code. So is this visible? Okay, yeah. So you just say new, and you choose your language, Python 3, and you get a new notebook. And anyone who's done anything close to data science has probably used one of these. So I'll just say something really simple and print out. What should I print out? No, that's boring. What do I print out? Yeah, okay, hello Aquava? Do people say that? Okay, there we go, hello Aquava. So I can basically run Python code in cells, right? And yeah, where's my slide? Okay, yeah. And it's pretty cool, because if you have to write scripts for certain things like visualization, it gets hard to have that flow and have that pipeline where you get from data, messy data to clean data, and then having to actually train a model. So Jupyter Notebooks have changed a lot. And before we get deeper into Jupyter Notebooks, I want to talk about lungs. I'm assuming everyone has lungs? So everyone knows what lungs are, right? Show of hands. Great. Okay, so like in the human body, we have these things that help us breathe. So you're literally alive because of your lungs. But I want to talk about bad lungs. So it's very hard to diagnose diseases that affect the lungs and the respiratory system as a whole. So this was a huge problem. I found a data set of about 100,000 chest x-rays. And what we had was a massive labeled data set and a huge problem to diagnose lung diseases. So what do? Machine learning, right? Yeah, because it's the cool thing to do. But then this is the right thing to apply the cool thing to do. Yeah. So notebooks are great. And I'll show you how. Just give me a minute. Where are we? Don't judge my folder names. So what we had was a huge problem. We had a massive data set that luckily was labeled, and we wanted to be able to classify chest x-ray images and say what disease a patient is most likely suffering from, with an amount of accuracy, of course. So I'll just browse through quickly the notebook, because we did a lot of visualization. We had to import the data and see what actually what features. Yeah, we had to see what features would help us classify and determine what type of diseases or what type of condition was affecting someone. So I'll just skip to a little bit lower. Yeah, okay, so you can see the titles, and then we have to prepare the data. It's like a whole process. And Jupyter Notebooks make this really easy. And then this is something that everyone would have to do at a point. So we have something called a model, which we can test and then use to predict data that the algorithm hasn't seen before. And then with some accuracy, we can get a prediction. So we put in an X-ray image into the model, and it says this person probably has lung cancer or pneumonia. And here, all we're doing, I want you to pay attention to this history. So all we do is fit a model, and we used a concept called transfer learning. It's a very interesting concept, because I want all of you, and it's a very integral part of this presentation, because a big problem that we faced was compute power. We have 100,000 images, and I only have an i7 with barely a GPU. And this is image data, and to train that would take so much time. But there are many tools, lots of cloud services that give you machine learning platforms where you can put up a Linux kernel, put in and install Python and train your model. You have access to infinite GPUs, but yeah, it makes everything much, much easier. So there's so many options. I don't want to push anything to you, but yeah. Once you do this, you train your model. Everything that you can put in, no matter what lung, chest x-ray you put into the model, it will give you, with a certain % of accuracy, an analysis and a prediction that says these are the most likely diseases that this person who took this x-ray is suffering from. So what we do is we train the model, and I want you to pay attention to to this. So with our data, we're able to reach about 91% accuracy, which I must say is a bit skewed because a majority of the images that we took in our data set were for a specific lung image, and I think that was a constraint on the part of the data set and not on the algorithm. Nonetheless, another thing I want everyone to pay attention to is this, because this is practically what makes our web application. So we have this model save weights, and we name our model model.h5. So this is the format that most machine learning models can get saved into. I was talking to someone earlier about a better way to do this, and they're still coming up with it. I'm happy to say that they're still coming up with it, so my talk isn't that outdated. Yeah. So we save the model, and we can put this in our project directory. And now I'll go back to my slides. So yeah. Oh no, one more thing, actually. So we save the model, but in our notebook Python environment, how do we check or predict anything? I think everyone's asking that, right? Nope? Are we together? Yeah. Okay. Are we together? Yeah. Okay. Yeah, so I mean, you're probably wondering, how do we predict something? How do we test it? And so more training, and we'll get there. So what we want to do is test out our model. Yeah. So we feed in some data here, right? This is what we're doing here. And then we store the prediction. So model.predict is what we use to actually predict. I'm sorry for my terrible naming conventions with my variables. Yeah. So we get an image here in this line, image path. We get the path to an image, and we pre-process it a bit. We turn the image into an array so that computers can understand what's going on, and then we use model.predict to actually make a prediction, and we save that in the preds variable. And if we print the preds variable, this is what we'll get. And this is not much value to anyone in this state, I'd assume, unless someone is that good at whatever. But yeah, this is of not much value. And what we want to do is to be able to display this alongside the possible diseases, because these are percentages of possible diseases. And that's why I say, yeah, notebooks are great, but how would this work in the real world? You won't tell a doctor to go into his Jupyter notebook and start to type model.predict X and start importing image files. It just doesn't work, right? Yeah. So I'm here to show you how. And summary, this is just a talk about Flask, TensorFlow, and OpenCV, so nothing complicated. Yeah, I think I already touched on the compute power. It was also a huge problem that we faced coming to building this project. So I want us to think of a mind map. In our heads, we have a Jupyter notebook, and we have a model that's stored, right? And we can access this model with Python. But we want to be able to get an image from where it comes from and put that into, and predict using our model, and use that to predict and actually show what's going on to someone who wouldn't be as tech savvy as us. So what I'll be going through here is a very basic architecture. How to implement that, I've talked a bit about that, but I'll get deeper into it, and how to deploy it. Cool? Cool? Yeah. All right. Yeah, so of course, instinctively you'd think, okay, let me have a client, let me have a server, right? The client queries the server, but we have a problem. Our model's in an H5 file. How do we do that? Cool. So should I demo it? Yeah. Do you think it works? No. Thanks for the confidence. Yeah, so let's do it. Is this visible? You can see this, right? Okay, so let's close that. And then I'm using Anaconda, so what I want to do is exit the Anaconda environment. I forgot how to spell. Okay. Should be. So yeah, like I mentioned, client, server. Let's check that out. So this I built using Particle.js. It's just something that looks a bit flashy, but nothing fancy. So I call this respiratory buddy, AI for good. This is just, yeah. So diagnose, click diagnose. It's very minimal. Don't judge my design. This is Python. Yeah, so I have like an X-ray here that I will put into it, and we press go. Did I press go? I should zoom in a bit or zoom out. Okay, so you didn't see the cool things happening in the background, but there's the X-ray, and these are the possible diseases that could be in that X-ray. So it works. Yay. Yeah, except for the lungs. But yeah, that's not in our power anymore. Let me just close that, go back to the presentation. Okay, so we're done with the demo. But I want to take you through how the application actually works. Can I do that?
Of course.
Yeah?
Yeah.
Okay, so let's see how everything works. I use VS Code. I hope that's okay. You've got no choice. Yeah, no, answer, please. So this is how, it's not very clear, is it? Should I zoom in more? Okay. It's a bit messy, my bad, but we have the model here. It's really important to have the model in like the source directory. And we have the file code server, which I ran to get the application going. And we import a bunch of things that help us do the work. And we have a bunch of functions. And I'll go through those functions. But I want to go to the bottom of the file and show you the route that we used. So what we have is this route, classify URL. So what this does is call a function up there.
Can you make this sidebar smaller?
Oh yeah.
Close the terminal. That way it's easier to read.
Thank you. Cool, okay. So I want to highlight this function, predict. So what we're doing here is we're loading in the model. VS Code. Okay, yeah, what we're doing here is we're loading in the model and feeding in the image. We get the image from the system because we uploaded, right? So here is the function to load the image from the URL and then turn it into an array so that the computer can understand what's going on. And another important thing is pre-processing everything. We have to crop the image so that it can fit the parameters of the model, and we have to invert the colors. So these are a few functions from OpenCV that do that. And yeah, we return an image which we pass here to turn into an array, which we then pass into the predict function, which predicts everything. But I'm guessing you want to have a look at the HTML. How many people here are comfortable with HTML? Great, thank you. Yeah, this should be it. Oh no, that's the landing page. Okay, so we have a few functions, and where is this? Yeah, beep boop loading. We have the button. So basically what happens is you press the button and a function is called, and that function then calls the predict function, which predicts and then displays the information on the web page. So it's really just putting HTML and Flask to work together to push data around both file types and then display that data that you used in the model, and there's your classification. I'm a bit disappointed because then I feel like it should have been a bit more complicated, but then that's the beauty of it. It's not that hard, right? Yeah. Yeah, it's not as complicated as many people make it seem. But this being my very first PyCon, by the way, I've met a ton of interesting people, have amazing conversations. And one thing I talked about that I had to add into my slides was the way the model, imagine having to retrain the model and then feeding it back into the app. So this project is on GitHub. At the end, I'll give you a link if anyone wants to have a look and tweak it and contribute or fork it, make your own thing. I've had a friend who built an application to check skin conditions, and that was pretty cool. So you can play around with it and do with it as you wish. And yeah, so imagine I want to retrain the model and put the model back into my application. That means having to go back to the notebook, training everything, doing the analysis, and then saving the model, taking the model, putting it in the source file. Then if you change the name, you have to change the name in the file also. And it's not the best workflow, right? And the ideal scenario would be to have the model hosted and be able to query it and get the results and then display them in some sort of function. You run that part as a function. And that would be cool. And if anyone at the moment can figure it out and find a better way of doing that. I think I missed a talk about how to do something similar with Redis, and that's amazing. And that's something that at the moment is a problem with the project and could be done better and probably will be done looking at the crowd. So that's basically how to create a disease classification web application. Another thing you all have to remember is this is very domain specific. So this is lung diseases. You'd have to tweak the IPython notebook, the Jupyter notebook, a lot to actually get it to work for data that you have. So you can do this for any data that you have, be it image data, be it text data, be it audio data. It's bound to change. But then this is my specific implementation for a problem I had, and you can change this as you wish, as I mentioned before. And because we're embracing open source software, you can go to that link and contribute. I'll give you some time to take a picture or, I don't know, write it down. Yeah. I'll have water. Oh no, I'm not done. Oh, that's fine. Yeah, I'm done, but I just wanted I just wanted to let you know that I really need feedback for how this talk went. So just while people are asking questions, you can just take that down and yeah. So you can go to that website. I don't know if it's visible, but if you want to tweet me, Instagram me, what else do I do? Yeah, just that. Feel free. Thanks. Thank you.
I'm on the schedule. So I'm literally just going to take one question, make it a good one. Yeah. Yeah.
Thank you. Your project seems nice. What is the percentage accuracy of your predictions?
Okay, so when we ran our when we tried to check the accuracy, it said 91%, but then I did mention that because our data set was a bit skewed, it wasn't as good as we think it is. So one thing that we wanted to take the project ahead is actually go into hospitals and do some sort of pilot and see how something like this would fit in that scenario. But with something as sensitive as chest x-rays, it's not something anyone can just say, okay, hey, come into our hospital and do this. But yeah, we are trying to actually get a better data set so we can train a better model and then be more comfortable with the accuracy that we are told we got. Yeah.
Okay, does anyone else have like a burning question? Oh, okay, I'm gonna, okay. All right, thank you so much, Jen.
Most welcome.